Salutations, Triglets! Welcome to another day of Trig on video. Alright, today is section 4.3. We're going to talk about properties of logs. Okay, other than being wooden chunks of a tree, properties of logs are very important, and we're going to be using these the rest of this chapter, so make sure you learn them well. All right, exponential properties, they correspond to log properties. So they're similar. So log props. They're very similar. So let's look at exponential here. If I have b to the m times b to the n, we know that becomes b to the m plus n. Okay, so for example, if I have x to the 4 times x to the 5th, that becomes x to the 9th. There's also a property, we'll call that number 1. Property number 2 is b to the m raised to the n, and that's a power to a power. Think of Power Rangers. When they cross their arms, it looks like an X, like multiplication. It becomes b to the m times n. Okay, so if I have b to the 4th raised to the 5th, that becomes b to the 20th. Now the log rules are similar. They have what we call the product rule. The product rule says that log of base b of m times n, you can split that into two logs. So we're splitting logs here. Log of base b m plus log of base b n. So you notice that the multiplication becomes addition. And that's kind of what happened in the other one. If the base was the same, we added the exponents. Okay, so we can expand. If you see the word expand, it means to expand something means to make it bigger. So if you think of expanding a log, you turn the multiplication into addition. So let's try one here. How about natural log of 7x? So you got to ask yourself, how many pieces do I have? I have 2, so this should expand into 2 natural logs. So natural log of 7 plus natural log of x. Okay, so there's 2 parts here. You should have 2 parts here when you split it. Let's look at this next one, log of 10x. So that becomes log of 10 plus log of x. Now, because we don't have a base written here, it's considered a 10. Now this, whenever you have the base 10 and it's equal to 10, you're going to get a 1. Whenever your base and your regular number are the same, it's a 1. So I can actually simplify this a little more and make it 1 plus the log of x. Okay, so if you have that, then go ahead and simplify that a little bit. All right, let's go to the next rule. This is the quotient rule. Quotient means to divide. So if I have log of base b of dividing m and n, so m divided by n, that turns into log of base b of m. Now division turns into subtraction, so log base b of n. So let's try one. So log base 7 of 19 divided by x. So again, I have 2 parts here, so I'm going to split this into 2 parts, but with subtraction. So it becomes log base 7 of 19 minus log base 7 of x. Log base 7 of 19 we can't figure out at this time, so we're just going to leave that. Okay, so if it's just telling you to expand, you don't really have to figure it out. Let's try another one. Natural log of e to the 3rd over 7. Okay, so 2 parts. I'm going to say natural log of e to the third minus natural log of 7. Now remember, natural log has a base of e. Okay, so look at this part here. I have e and e to the third. That reduces to a 3. And then this other part is just natural log of 7 because I don't have an e in there. All right, let's look at the power rule. One more rule here, or the next rule, the power rule. Okay, this says that if I have log of base b of m to the p, the power, that p comes out front and it's p log base b of m. Okay, so anytime you have an exponent, you bring it out front as a power. Let's try an example. So natural log x squared, that becomes 2 natural log of x. How about the log base 5 of 7 to the fourth? That just becomes 4 out front and log base 5 of 7. So it's just really moving it out front. Now, sometimes it comes in disguises here. So for instance, if I have log of square root of x, that's really saying log of x to the 1/2. Now I have a power, so that power can be brought out front. So 1/2 log of x. So you have to watch out for those disguised exponents. Let's try one with a little more complicated power here. So log base 5 of x plus 2 squared. Okay, now because this is in parentheses, I don't want to break that up. Okay, so I can bring the 2 out front, and I have log base 5 of x plus 2. Okay, you don't want to break that up, and because it was squared, we might have to put in a plus or minus sign when we actually go to solve this, because it was squared, meaning this could be plus or minus, because squaring it always brings it back to positive. But again, we'll try that, we'll talk about that one later. All right, let's try a few problems here that are all mixed up with all these rules and see how we do. So log base b of x squared times the square root of y. All right, first of all, some steps here are we want to change everything to exponential form, or to change all the exponents, or sorry, to change into exponents. So in this case, I have log base b, x squared is an exponent, y with its exponent would be y to the 1/2. Okay, the next step would be to expand. You're going to use the product or quotient rules. Okay, so let's try that. I have 2 parts, so I'm going to expand that out. So I have log base b of x squared plus log base b of y to the 1/2. The third rule is to use the power rule. So bring all those powers out front. So this x squared becomes 2 log base b of x. This 1/2 comes out front, and then it's log base b of y. Okay, so follow these rules as to how you're going to expand. You have to do it in that order. All right, now we're going to do a whopper of a problem here. Let's try this one. Log base 6 of the cube root of x over 36y to the 4th. Okay, we really have to follow those rules. So first we're going to change everything to exponents. So I have log base 6. Cube root of x is really x to the 1/3. And then the 36y to the 4th is already in exponential form, so we'll leave it. Okay, now we need to expand using the product and quotient rules. So how many parts do I have? I have 1, 2, 3 parts. Notice the 36y to the 4th is on the bottom, It's all together, so that has to stay together in like brackets. Okay, so let's try this. So log base 6. First we're going to do this one, so x to the 1/3. All right, now we are going to subtract because it's division. And then the rest of this, since these are multiplied together, they're going to become addition inside the brackets. So I have log base 6 of 36 plus log base 6 of y to the 4th. All right, so we expanded that into the quotient and product. All right, so next we have to bring down the exponents, bring them out front. So that 1/3 comes out front. Then I'm going to distribute this negative sign into each. So log base 6 of 36, we don't have any exponents, so we leave it. And then this minus times that plus makes it minus. Bring the 4 out front, so 4 log 6 of y. All right, we're getting there. The last step is to simplify anything that's possible. This one, log base 6, I don't know, so, and I have an x in there, so I can't really do anything of that. Now, what about this one? There's no variable, so 6 log base 6 of 36. That's saying 6 to the what equals 36. So I can evaluate that if I set that equal to x and I actually set it into the exponential. So 6 squared equals 36. So that really all reduces down to a 2. And then the last part I can't really do anything with because I've got variables and I don't know log base 6. So I just leave it. So there we go. All right, so figure out how many parts you have, decide if it's going to be addition or subtraction, but whatever you have, either numerator or denominator like this, has to stay together in brackets. All right, we got a little bit more here. What if we want to condense rather than expand? So condense means we have to go in reverse. All right, so the first step is to put the powers back. The second step would be to write 1 log. So write the word log once. And then the third is to change back to multiplication or division. Okay, so we're working in total reverse order. So let's say I have log base 4 of 2 plus log base 4 of 32. Okay, are there any exponents? Are there any powers out front? No, so we don't have to worry about that step. Now I want to write the word log one time, and ours is log base 4. And then the 2 plus and the 32 means it's 2 times 32. So I really have log base 4 of 64. And can I evaluate that? What that's saying is 4 to the what is 64. And 4 times 4 times 4. So my answer here is 3. So all of this equals 3. All right, let's try another one. So log 4x minus 3 minus, whoops, log of x. So do I have any powers out front? Nope, doesn't look like it. So I'm going to write the word log once, and it's base 10, so we just leave that. Then I have this minus this. So the minus turns into the division bar, and then we just have that. And there's really nothing else you can do for it, so we just leave it. All right, I have 2 more examples, and then we have 1 more rule. So this is moving along here. Let's keep going. So 1/2 log of x plus 4 log of x minus 1. All right, I do have some powers, so I'm going to put those back where they belong. So log of x to the 1/2 plus log of x minus 1 to the 4th. The next thing we do is write the word log once, and then we decide what we have. We have a plus sign, so it's going to be multiplication. Now x to the 1/2 can be written as square root of x. I'm going to take it either way, but then turn your plus sign into a times, and then you have x minus 1 to the fourth. And then you need brackets around all of that to say that it's the log of everything. All right, I think we're doing pretty well here. I've got one more example and then one more rule here. So 4 log base b of x minus 2 log base b of 6 minus 1/2 log base b of y. All right, notice we have 3 parts. I do have some powers, so let's put those back. So log base b of x to the fourth, log base b of 6 squared, minus log base b of y to the 1/2. Okay, now, see I have 2 subtraction signs here. We're going to turn that into 1. We're going to undistribute that subtraction sign. So what I have is log base b of x to the fourth minus parentheses log base b, now 6 squared is 36, plus log base b of y to the 1/2. Okay, the reason I need to do that is because those are going to be together on the bottom of the log. So let's keep going here. Log base b of x to the fourth minus, I'm going to put these two together as 1, so I'm going to write 1 log and then 36 times y to the 1/2. So 36 y to the 1/2. Okay, we're getting close. Now I still want to put these together, so I do 1 more log. So log base b, so I'm going to take these 2 and turn them into 1, and then x to the fourth minus turns into division, 36y to the 1/2. All right, the only other thing that might have to occur is because we have y to the 1/2 in the denominator, you can write it as square root. You might have to get rid of that radical in the bottom by multiplying top and bottom. Okay, so just be prepared that your answer might look a little different than the books. Okay, last idea here. Rule number 4 is called the change of base rule. Now this is a nice handy dandy rule. If I have log base b of m, I can break it into log of m over log of b. And this becomes the common log of base 10, so you can do it on your calculator. For example, log base 5 of 140. Can't do it because I don't have a log base 5 calculator, so I'm going to say log of 140 over log of 5. Use your calculator to type those in. You should get 3.07. Okay, and that works with natural log too. All right, Fast and Furious. Thank you for listening. Trig love is all around you. Ta-ta.